Next, we're going to add and subtract complex numbers. When adding or subtracting complex numbers, simply add or subtract the real part, and then add or subtract the imaginary parts. Then make sure that you leave all your answers in A plus BI form. So on the first problem, we have an addition. So because it's addition right here in the middle, is going to be a pretty simple problem. All you have to do is take the real parts and add them. -4 plus 3 is -1. And then we take the imaginary parts, plus 7i plus 2i, and add them and get plus 9i. Now on the second problem, we have a subtract sign. And because it's a subtract sign, it makes it a little bit more difficult to subtract. When we have 3 minus 7, sometimes usually people get that, but when we do the imaginary parts, people forget to distribute that negative. So I'm going to go ahead and take a first step just to distribute the negative, or like that -1. So that gets me -7 minus 4i. The first parentheses just stays the same. I'm just going to go ahead and bring it out. Then I'm going to add or subtract the real parts. 3 minus 7 is -4. And then add or subtract the imaginary parts. -5i minus 4i is -9i. And I am done. So that's just one extra step if it's a minus. So on this next problem, we have one part that's minus and then another part that's plus. But let's just take a minute to distribute those and take them all out of the parentheses. So the first one's 2 plus 3i. That doesn't get anything distributed. On the second one, I'm getting -1 plus 4i. If you're writing -4i, you're not distributing the negative to both. And then the third one is plus, so I don't need to really worry about that. I can just bring that one right out of the parentheses. And then I'm going to look at all of the real parts and add them. Well, I have 2 minus 1, which is +1. And +1 minus 2 more is -1. And then in my imaginary parts, 3i plus 4i is 7i plus 3 more i's is plus 10i. Notice all of these are written in the form the real one plus or minus the imaginary one, a plus bi form. Next, we're going to multiply. When we multiply complex numbers, we're going to use the following steps. Step 1. Use the distributive property if necessary. Replace any I squareds with -1. That comes from the formula I squared is equal to -1 from the first page. Step 3. Simplify and leave your answers in the form a plus bi. Be sure to put the real part first. Normally, I don't really care if you put the variable first or the number second. Like if the answer was x plus 3 and you wrote 3 plus x. Well, I would give both you and me the credit. Okay, we both get credit for that. But in imaginary numbers, it must be written in the form a plus bi. So if I have 2 plus 3i, but you wrote 3i plus 2, this is not going to be okay. It's not that I'm being picky, it's just that complex numbers need to be written in the form a plus bi. So on the first problem, we have 8i times 3i. When I multiply those, I get 24i squareds. In variables, if this was like x, I'd be done. But because it's not x, it's an I, step 2 says replace any I squares with -1. So then I can do that one more step and gets me -24. So the answer is just -24. Now this first problem is really cool because 8i and times 3i, that's two imaginary numbers, and two imaginary numbers multiplied together to get a real number. This is going to be very helpful for us when we do division and we're trying to get the i's out of the denominator. So be looking for that in this upcoming lesson. On the next problem, I'm going to distribute the 4, so that gets me -4 plus 20i. There's no I squares, and it's already in the form a plus bi, so I am done. On the next problem, I'm going to double distribute. The negative 1 needs to multiply to get 5 plus 6i. And then I'm going to come and grab the negative 2i and distribute that as well to get negative 10i minus 12i squared. Step 2 says replace any I squareds with negative 1. So this last term, negative 12i squared, is going to be replaced with negative 12 times negative 1. Now I'm going to simplify by combining any like terms. It looks like the 6i minus 10i, that adds to negative 4i. Negative 12 times negative 1, that's positive 12, which I can add those two numbers together, get 17. Because it's real, it goes in the front, and the minus 4i goes in the back. On our next problem, we're going to distribute negative 1. Negative 1 times negative 1 is positive 1. Distribute negative 10i. Then I'm going to come back and grab the negative 2i, and that's going to distribute as well, which gets plus 2i minus 20i squared. Step 2 reminds us that we need to take any i's and replace them with negative 1. The two middle ones look like they can add up. That's negative 10i plus 2i was negative 8i. Negative 20 times negative 1 is positive 20. And then I add those real numbers to get 21 minus 8i. Notice that I'm always putting the real number in front and the imaginary in back to put it in a plus bi form. On our next problem, we have a binomial squared. Please do not think that you can distribute that squared. You can't do that over a minus or a plus sign. So instead of trying to distribute your square, we're just going to write the binomial twice because that's what squared means. Squared means multiply by itself. So and then I'm going to distribute to get 16 minus 4i minus 4i plus I squared. Now I squared is equal to negative 1. So I'm going to replace that with a negative 1. Okay, so now I'm going to combine like terms. It looks like the two middle terms add up to be negative 8i. Those do not cancel out or add to 0 because they're both negative, so that makes it a bigger negative. 16 minus 1, that's 15, and that is my final answer, 15 minus 8i, which is in a plus bi form. Now take a look at this last one. These two binomials are very similar, but only off by a negative in the middle. Do you remember what we called that from our last lesson? This is called a conjugate pair. But because they're complex, we can call them more specifically a complex conjugate. This had some special properties in our last lesson, and it's going to have some special properties here as well. Let's just go ahead and distribute like normal. 3 times 3 is 9. 3 times 2i is 6i. Distribute the negative 2i to get minus 6i minus 4i squared. The two middle ones add to 0, and then I get 9 minus 4 times I squared. But in step 2, we're reminded that I squared is equal to negative 1. You can never have any answers with an I squared in it because you can always change it back into a real number. So negative 4 times negative 1 is positive 4, and then I add those two together and I get 13. So this is pretty amazing, kind of like the first one. We had a complex number times another complex number, and it gave us a real number. That's pretty amazing. So whenever you multiply two conjugates together, you get a real number. That's amazing. Remember on our first problem, we had a purely imaginary number times another purely imaginary number, and we got a real number. These two properties are going to help us when we're going to be dividing by complex numbers. So just like we were talking about, it says that notice that the last pair was a conjugate pair. When you multiply conjugate pairs, the answer is always going to be a real solution. This will be very important when we divide complex numbers.